Yes. Yeah. Morning all. Yes, sorry for the delay. Evolution of Apache Spark. It was developed by Matthijs Heria in AMP Lab Berkeley in the year 2009. It was open sourced in the year 2010. Spark was donated to Apache Software Foundation in the year 2013. Spark is an open source distributed cluster computing framework with in-memory computing feature in parallel processor style used for large-scale data processing. It's a general engine for big data analysis, processing, and computation, right? So PySpark used for running distributed SQL, creating data pipelines, running ML algorithms, working with graphs, working with data streams. Spark can be coded in multiple languages like Python, Scala, Java, and R language. By default, Spark built using Scala language. Scala is the native language of Spark. Scala is scalable language that is extension to Java language. So whenever you say Spark means with Scala implementation, if it's a PySpark, Spark with Python implementation, right? I was just showing you the differences between Python and Scala. Python is dynamic typed, Scala is statically typed, and Python is open sourced and has got huge community. It has got thousands of modules, 89,300 modules. Scala has got smaller community as compared with Python. Python has got powerful libraries for machine learning, graph, and streaming. Scala has got less libraries. Python is slower as compared with Scala. Scala is faster than Python. As Python is interpreted like it is slower as compared with Scala. So difference between Azure Data Factory and Azure Databricks. Yes. It's a data integration service and data ingestion and data Azure Databricks is for big data analytics. Data transformations, only basic transformations using data flows you can do in Azure Data Factory. Advanced transformations using PySpark. Azure Data Factory is codeless. Azure Databricks is code-based, customized code we can write. Development interface, it's a graphical user interface. Azure Data Factory for creating pipelines. Azure Databricks is notebooks for interactive data analysis and development. Scalability scales through integration with other Azure services. Here, highly scalable with a built-in Spark cluster and various execution engines, right? MapReduce, Tej, and Spark. Tej and Spark both follows DAG model, but Tej doesn't follow in-memory computation. But Spark is an in-memory computing system. Spark has got a very high speed as compared with Tej. Other in-memory computing systems in the market are SAP HANA. If you compare HANA and Spark, both follows in-memory computation, but HANA is not distributed. Spark is a distributed RAM. Spark is mainly designed for batch application. Batch means batch applications, millions and trillions of records. And user non-interactive applications, we call it as batch applications. It is mainly for iterative algorithms. Most of the ML algorithms are iterative in nature. Interactive queries for SQL queries and for streaming. Spark is 100 times faster than normal disk processing. Spark is 100 times faster than Hadoop MapReduce. Spark supports advanced analytics for machine learning, algorithms for graph algorithms for streaming, for interactive queries. And if you say Spark and the Hadoop, in case of Hadoop MapReduce, transformations cannot be reused. But for iterative algorithms, not a flexible parallel process because in MapReduce, mapper phase executes first, next reducer phase executes. But MapReduce is meant for parallel processing. So it's not a flexible parallel process. and slow processing as compared with Spark. Spark is 100 times faster. Apache Spark and Pig both are data flow languages, but in Apache Pig, the entire data flow is again converted into one MapReduce job. But again, MapReduce is bad. And Spark and Flink, both purpose and objective is same. Both are introduced by Apache Software Foundation. But first Spark was introduced by Apache and later Flink was introduced. In the initial versions of Flink was dominating Spark. The heart of analytics is machine learning, but in the initial versions of Spark, Spark was weaker in terms of machine learning. But from Spark 1.6 version onwards, Spark introduced powerful libraries for machine learning, graph algorithms, streaming. Before Spark 1.6, Flink dominating Spark. From Spark 1.6, Flink equal to Spark. From Spark 2.0 version onwards, Spark totally dominating Flink. Spark features in-memory computation, distributed execution, flexible parallel process, high speed, multi-language support, good for iterative algorithms, supports advanced analytics, lazy evolution. If action performed on if action performed only, they execute. Persistence. Already executed transformations can be reused. Partitioning. Spark data is divided into partitions so that they can execute parallelly, right? We talk about now Spark data objects. So previously like RTDs, but just I'll give some knowledge on this RTDs. Currently like data frames are mostly preferred. Spark RTDs. Resilient distributed data sets we say, right? Spark data objects are called as RTDs. RTDs are subdivided into partitions. RTDs are subdivided into partitions. These partitions are distributed. RTDs are subdivided into partitions. These partitions are distributed across multiple worker nodes. These partitions are distributed across multiple RAMs of multiple worker nodes. RTD programming style. Data flow. RTD programming style is data flow. Data flow is a sequence collection of pipes. A pipe is a data operation. A pipe is a data operation such as loading data, transforming data, filtering data, grouping data, right? Merging data. It is a data operation such as loading data, transforming data, filtering data, grouping data, merging data. In Spark, data flow is executed in sequence. Data flow is executed in sequence, that is RTD by RTD, RTD by RTD, one after the another, one after the another. Within memory computing feature and the persistence feature. Within memory computing feature and persistence feature. But if a RTD has 30 partitions, since Spark data flow is executed in sequence RTD by RTD one after the another with in-memory computing feature and persisting feature. But if a RTD has got 30 partitions, then all the 30 partitions, generally RTD is a Spark data object. Spark data object, that is RTD, will be divided into partitions. Assume it is divided into 30 partitions. For example, RTD divided into partition, say RTD P1 partition stored in system 1, P2 partition, system 2, P3 partition is divided into multiple partitions, P3 into system 3. All these 30 partitions, all these 30 partitions are stored in 30 systems and are executed parallelly. All these 30 partitions are stored in 30 systems and are executed parallelly. Okay. So see here in the generally in the we'll be using a data frames. Data frames is nothing but RTD with a schema. An RTD with schema is called a data frame. So just some knowledge on this RTD before we go with the data frames. An RTD, like two types of operations can be performed. Transformations and actions. Transformations, three types. Each element a transformation. Example like map, flat map. Three types of transformations, three types, each element transformation, filter transformation, aggregated transformation, right? Yes. Each element transformation, filter transformation, and aggregated transformation. Map, flat map. Example. If 1 lakh employees, adding 5,000 to the salaries of each employees. See, if you want to add 5,000 to the salaries of each employee, 1 lakh employees, right? Each element transformation. Whatever transformation you want to perform to each and every element, each and every employee. If 1 lakh employees, transforming each employee name to start with uppercase. Transforming each employee name to start with uppercase character. RTD.map, RTD.flatmap. Filter transformation. Filter based on a condition. Map, okay, map. These are the two used for each element transformations. Map, if you want to map some transformation to each and every element, if you want to map some transformation to each and every element, right? So like adding 5,000 to the salaries, if you want to map any transformation to each and every element. See, whatever transformation you apply should be applied on every element. Flat map is for flattening the elements, for flattening. For flattening, right? Yes. For example, one, two, three, 4, 5, 6, 7, 8, 9. After flattening, you will see the output like this. 1, 2, 3, 4, 5, 6, 7, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, you will see. After flattening, means here list of lists. After flattening, you will get everything as one list. Aggregation transformation. Grouping and aggregation. Example, we have got functions. So for groupings and aggregations, right? Yes. We've got functions like group by key, reduce by key. For groupings and aggregations. So in RTD, two types of operations. On a RTD, two types of operations. One is transformations, one is actions. When an action is performed on a RTD, when an action is performed in a RTD, then only the data flow will be executed from the root RTD. When an action is performed on a RTD, then only the data flow will be executed from the root RTD. Some
What
of
is
the
that reduced by key?
some of the actions are, see, reduce by key, group by key. These two are there. Group by key, reduce by key means just observe. For example, group by, okay, reduce by key is there. What it does is, for example, I want, for example, you got some employees data. You got some employees data. I want department number wise total salary. Department number wise total salary I want. For example, first employee belongs to department 11, some marketing department. He has got some 30,000. Second person, department number 12, like sales department, some salary 40,000 he has got. Third employee, again department 11, 50,000. Next, 60,000. Department 13 means some HR department, 70,000. Department 13 like 10,000. Now, whenever you say reduce by key, whenever say reduce by key, this is key, this is value. Assume this is key, this is value. You will extract only these two. So reduce by key means you want a department number wise salary, key value, total salary. Department number wise means for department 11, what are the total salaries given? Department 12, what are the total salaries given? Department 13, total salaries given. Department number wise reduced by key. If we say all the department number 11s, all the department number 11s, for example, 30,000
Eight.
plus 50,000 will submit. Similarly, for department number 12, the just like reduce by key, it groups and aggregates. For department 12, what are all the salaries? 40,000, 60,000. For all the department 13, 70,000, 10,000. Means it reduced by key, what it is going to do for a particular key level, what all the values are available, it will sum it.
This is nothing but group by, right?
Good. Okay. So 11, it performs sum. So you will get this value. You will be getting these values like this. Reduced by key. Group by key is what? Group by key is what?
Sum of salary group by value.
Group by key, what it is going to do is it will group all this. It will just uh 30, what are the values? It won't do any operation. It will just groups it. It will groups it. And later, here we can perform in the case of reduced by key, here you performed some aggregation. One aggregation like it will sum it. You will get 11, 80,000 as this. 12, 1 lakh, 13, 80,000 like this. But here it won't do any operation. It will just groups it. Here it will perform some aggregation like reduced by key. Perform some aggregation directly. It will apply some aggregation on it. Here it will group it. Later after grouping, what operation you want later, again in the next step you will do in this, you will get one group like this. You will get a group, a array. You're going to get an array like that. On that, if you want to perform sum, you can perform sum. If you want to perform max or min or average or count, all multiple aggregations you can perform. Once if you are grouping, here reduce by key directly it applies sum. Reduce by key, it will totally for all that particular key, it will perform sum directly, it will perform the sum, or if you want order operation. But here it will just to group it. In case of group by key, it will group all the department number 11's values, all the department number 12, all the department number 13. Later you can perform this. On this, if you're applying sum, you will get total sum. If you're applying max, you will get the max value. If you're applying min value, in this way you get. It groups it. Yes. Those are directly built-in functions available for groupings and aggregating, right? For grouping and aggregating. Some of the, okay, when an action is performed on a RTD, then only the data flow will be executed from the root RTD. Until then, it won't be executed. Some of the actions are, see, in Spark, if you want to execute that entire flow, some action to be performed. If action performed only, it executes. Spark is lazy evaluated, just like functions. If you define functions, they won't execute. Until you need to make a call, they won't execute. In same way, by defining a data flow, until you perform an action, they won't get executed. So when an action is performed, right, then only the data flow will be executed from the root, from the starting to the S. Some of the actions are like collect. It will collect all the partitions. It will collect all the partitions of different slave machines. It will collect all the partitions of different slave machines of different machines. It will collect all the partitions of different machines. This Spark data is divided into multiple partitions. That multiple partitions are distributed across multiple machines, multiple systems. So whenever you say collect, it will collect all the partitions of different machines. RTD dot collect. We have got count. Returns the number of elements. Returns the number of elements in a RTD, like RTD dot count. Take of n. Takes the first n number of elements. Takes the first n number of elements in a RTD. Takes the first n number of elements in a RTD. So we have got many actions. Later I'll be discussing, but here RTD programming style is a data flow. Data flow is a sequence collection of pipe. At each pipe, some operation is going to be performed. Understand here? If I'm taking a flow like this, R1, See, R1 is an RT. Okay, fine. RTD1. How this RTD1 is created? If you load a text file, if you're loading a file, right? RTD gets created using Spark context. If you load text file path, RTD1 gets created. On RTD1, you perform some operation. On RTD1, you perform some operation, filtering operation or grouping operation, any operation. RTD2 gets created. On RTD1, if you perform any operation, any transformation, RTD2 gets created. Means the output of RTD1 is input to RTD2. The output of RTD2 is input to RTD3. So if you are performing any transformation or filtering on this, the output, whatever you get, is a new RTD. So RTD4. So initially there was only one RTD. That RTD was created from whenever you're loading a file. Later RTD2 got generated on RTD3, RTD4. Think that each RTD is a bigger data object. 1 TB. 1 TB of size. How this RTD2 got created? On RTD1, if I perform filter, RTD2 got generated. Again, from RTD2, if I perform some grouping activity, group by, RTD3 got generated. Again, from RTD3, some mapping operation, some mapping transfer, RTD4 got generated. So in this way, one output of one will be the input to the next, the output of one will be the input to the next. So for example, each RTD think its size is 1 TB. Where this RTD gets stored? Where the RTD gets stored? I said in-memory computation. Spark has got in-memory computation. Storage and processing happens within the RAM level, memory level. What think that you got some 10 RTDs. Means each RTD size is 1 TB, totally 10 TB. 10 TB is a lot, 10 TB of RAM storage. So maintaining that much huge RAM is see 10 TB, 10 TB, 10 TB, right, for 10 RTDs. So if we got some 40 RTDs, means 40 TB, that much of RAM capacity. See, for example, first thing is all the RTDs at a time they won't be loaded into the RAM. All the RTDs at a time won't be loaded into the RAM. If 40 RTDs are there, 40 TBs at a time, you cannot be loaded into the RAM. One by one, first RTD1 gets loaded. It computes. The output once collected by RTD2. Once the output collected by RTD2, RTD1 gets removed from the RAM. RTD2 output taken by RTD3, then this gets removed from the RAM. Once RTD3 is loaded into the RAM and computed, and the output is taken by RTD4, this gets removed from the RAM.
Then that is like sequential only, right? This is not
Once,
like parallel.
once, I'll come to it. So once RTD4 also loaded and computed, see, once the output is loaded and computed, this also gets removed from the RAM. Now, how many RTDs in the RAM? Hmm? Everyone. How many
One.
RTDs in the RAM?
One.
Zero, zero.
Zero.
No RTD in the RAM. Means once the output is collected by this final RTD, that final RTD also removed. You can trigger the next flow. If one by one RTDs, if they are not removed, if there are 20 RTD in my data flow, if you got 10 RTDs or 20 RTDs, if you keep on loading the RTDs into the RAM, at a point of time, the total RAM will be full. There won't be any space available for the upcoming RTDs to be loaded. So what happens here? Resilient RTD full form is what? Resilient distributed data sets. Here they get loaded one by one, they get removed one by one. See here you are saying then where is the parallel processing happening means RTD1, that is your initial RTD, got created from your file. That RTD is divided into partitions. P1, P2, P3, P4, 100 partitions. 100 partitions stored in 100 systems, executed parallelly, or you will get the output. That is given to the next RTD2. Right? Here, you cannot execute two RTDs in parallel because the output of one is the input to the next one. If you're executing both parallelly, what is the input to RTD2? Until RTD1 execution completed, the output has to be taken by RTD2. Until then, RTD2 cannot execute.
Okay, then RDD is not like system or node.
So one more question asked then, good query, right? If it is removed from the RAM, how can we use it? You want to use the previous output after. Okay, yes. RDD is not. Okay. So here RTD is a Spark data object. So once one by one RTD gets loaded and it gets removed from the RAM. No RTD in the RAM. And next, if we trigger the next flow, in the next flow also, RTD by RTD, they gets loaded into the RAM. After processing, okay, one by one gets removed from the RAM. No RTD in the RAM. For example, observe this flow. R1, R2, R3, R4, R5, R6, R7, R8, R9, R10. This is flow 1. This we call it as flow 1. This one we call it as flow 2. This last one, this is we call it as flow 3. Three flows are there. In flow 1, try to say R1, R2, R3, R4, R5, R8. Flow 2 you say R1, R2, R3, R4, R6, R9. Flow 3 R3, R4, R7, R9. I want to execute the flow 1. Flow 1 to execute. Executing flow 1, right? Yes. First R1, R2, R3, R4, R5, R8.
So if we execute all three flows, it will go all, R1, R2, R3 three times.
See, what is RTD? I said. What
So
do you
it's
mean
a,
by an RTD? Spark data
it's
objects. See here, clearly I have typed here, right? What is an RTD? Spark data objects are called as RTDs. Data object. Again, RTD is data object subdivided into partitions, into multiple partitions. Multiple partitions are distributed across multiple RAMs of multiple worker nodes. So here I was saying, if you are loading a file, RTD1 got created, I said. If you are loading a file path, here this is a file or file path. If you are providing, RTD1 got created. RTD1, if I am performing some filtering, the output is nothing but RTD2 is created. Again, on that RTD2, if I am performing some transformations or filtering, Sandhya D, right? What is the difference between an RTD and a data frame? Data frame is something which has got like a structured, it has got a schema, right? RTD plus schema is nothing but a data frame. RTD doesn't have any schema, but data frame, like a tabular structure, its schema you will have.
Means RTD is data.
RTD, see here, RTD is, that doesn't have, means it is going to store your data. Later, see, generally RTDs will be just like, it will be like array type. By using indexes, you will be accessing the elements. You want to access the first element, second element, third element, you will be using indexes. So that's why later we got a data frames from it. On top of what it is, data frames. Data frames means like a tabular structure, like SQL table with headers you'll be getting. So that by using header names only, we can be accessing the data using data frames. On top of what it is, we got data frames. So data frames are mostly preferable because if you want to access any column, anything, any row, right, it will be very simple to access. But initially, RTDs on top of that. So majorly in our discussion, right, in Spark, majorly our discussion will be on data frames only, but some knowledge on RTDs. Initially, you need to have the some knowledge on this RTDs. On top of that, we'll go with data frames. So here, if I got a flow like this, a data flow, three flows are there. First flow is executing R1, R2, R3, R4, R5, R8. First R1 is the first data object, was created from a file. It gets loaded. Its output is taken by the next one. Once this R1 output is collected by R2, this gets removed from the RAM. R3, once it collects R2 output, this gets removed from the RAM. So in this way, when R4 is ready, this gets removed. One query was asked, if all the RTDs are removed, how can the RTDs output can be reused? Just 1 second. So R5 output is collected by R8, been removed. Once R8 output is collected by the client, then this also gets removed. No RTD in the RAM. It will trigger, okay, you can trigger the next flow 2. In the flow 2 also, right? R1, R2, R3, R4, R6, R9. One by one, they gets loaded. This one gets removed. This gets loaded. This gets removed from the RAM. Loads and the previous one gets removed. Previous. Once the output is collected, this also no RTT in the RAM. But if you see in the three flows, the first four steps are common. The first four steps are common if you are performing any operation. But still, every time the flow is re-executing from the starting. Just now someone asked, why can't you, in the first flow you already executed four steps, why can't you use this R4 output and compute? Why again four steps again you're re-executing them,
Yeah, that is my question.
right? So in the first flow itself you executed all this, why again you are re-executing from the beginning? So in such case, I said in Spark we have got one feature, persistence. Persistence.
Yes.
If you make a R4 dot persist, whenever you say R4 dot persist, then R4 won't be removed from the RAM. Means which RTD will be persisted means the RTD whose output is commonly used by multiple flows. Whose output is commonly used by multiple flows. That RTD will be persisted.
Hello, sir.
Yes.
Sir, flow one total are executed.
Mhm.
Then flow two also started with R4.
I'm coming to it. I'm coming to it. So here
Okay.
flow every time. What is the problem here? Every time flow one, flow two, flow three execute started. It's executing from the starting. It is re-executing again from the first. Even though the first four steps are common, every time it is re-executing from the beginning. So instead of that, what happens if you are persisting a particular RTD? What do you mean by persistence and what is the advantage of persistence if you persist a particular RTD means? Observe. This is your flow R1, R2, R3, R4, R5, R6, R7, R8, R9, R10. If you are persisting this R4 dot persist, if you are persistence is one of the important feature of Spark. First, what happens? Flow 1 you are executing. If you are executing flow 1, okay, flow 1 executes from the starting R2, R3, R4, R5, R8. So what happens? One by one, they get loaded to the RAM. Once this loaded and computed, the previous one gets removed. When R3 loaded and computed, R2 gets removed. When R4 loaded and computed. Observe here, when R5 loaded and computed, do you think R4 gets removed from the RAM? No. If you are persisting any RTD, it won't be removed from the RAM. No. This R4 will be available. When R8 ready, this gets removed. When R8 output is collected, this gets removed from the RAM. So how many RTDs in the RAM now?
One.
R4 in the RAM. R4 is present in the RAM, right? Why R4 you are making to be available in the RAM? So that R4 is mostly used by different my flows. Flow 1 is using it, flow 2 is using, flow 3 also using its output. So the output means the RTDs whose output is commonly used by multiple flows, that RTD will persist so that it is available to give its output to the many other flows. Now flow 2 if you are executing, flow 2 you are executing, compulsory any flow if you want to execute, you need to perform action. On which one you want to perform action? R9. R9 dot action. Whenever you say R9 dot action, then only this entire flow will be executed from its starting, from its root RTD. While 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 executing, first it will check, okay, I want to get the R9 output. I need to collect R9 output. First it will check R9 input is R8. Is it available in the RAM? No. R8 input is R4. Is it available in the RAM? Yes.
Yes.
So the flow starts from R4 to R8 to R9. So nearly 4 steps have been decreased. Previously, in flow 1 to execute, I need to say R8 dot action. It will check any RTDs available. R8 input, R5, R5 to R4, R4 to R3 to R2 to R1. So the first flow will execute from the starting. Whenever during the execution only, it will persist this first step. Whenever during the execution process, it will persist it. Once it is persisted, the other flows can start from this R4. Flow 3 also can start from R4. No need to re-execute from the beginning. In the previous step, nothing was persisted. So every time it was re-executing from the beginning. But if you are persisting, making the RTD available in the RAM so that the second flow onwards, you no need to execute from the starting. Any available RTDs from there you can execute so that the 4 steps are decreased. If you have got a very big flow, R1, R2, in this way R50, from R50 to R70, R80, R90. Three flows are using this R50 output. Then persist it. R50 dot persist method is there. If you persist it, what happens? First flow, this 70 steps executes. But from second flow onwards, directly from R50 to R80, no need to execute. 50 steps decreased. 50 steps decreased. Just now someone asked how can that RTD output can be reused. Here we are reusing. If you're executing the flow 2, this is your flow 2, right? This is your flow 2. If you're executing it, you're reusing the R50 output and you're just computing it. 50 steps got decreased for the third flow also. This is your third flow. Here also 50 steps got decreased. Understanding the importance of persistence.
It is something caching the data.
Yes, 1 second.
So every time the operation is completed, that particular RDD is removed from the RAM, right?
Yes, so if we every time the previous RTD's output is collected, so R1, R2, R3 if we take, once R1 output is collected and R2 is computed, then R1 gets removed. Once R2 output is collected by R3 and it's computed, the previous one gets removed. So what happens if you're loading one by one RTD into the RAM at a particular point of time, the total RAM will be full if they are not removed. So one by one they gets loaded, one by one they gets removed. Finally, all the RTDs will be removed. If you're persisting anything, then you persist it so that it will be available to give its output to the many other flows. Understood what I mean by persistence? What is the advantage of persistence? I'll be discussing much more clearly in the just it is an overview. I've discussed not only this for data frames, all these things, the same thing will be applied. RTD, resilient distributed data set. Resilient distributed data set, right? Yes. Okay. So yeah. So that is RTDs are the see Spark data objects are RTDs data frames and data
So
streams with RTDs are there, data frames are there, data streams are there for streaming data streams, data frames and RTDs. RTDs are the basic objects. From that RTDs, if you are providing schema, we get a data frame, right?
Sir, one last question, just about data size. So, is there any limitations to persist the data in RAM?
See, you'll be maintaining anyhow. If you are going with Spark means you will require huge RAM, right? Huge RAM means
Okay.
your data will be sitting into the RAM, right? In-memory
Yeah.
computation, RAM level computation, you need to your huge data one, for example, RTD1 from a file1.txt. From this RTD got created. This RTD size is like a 2 TB. This will be won't sit in a single system. This 2 TB will be divided into P1, P2, P3 into like 40 partitions, P1 into system 1, into RAM 1 of system 1, into RAM 2 of system 2. In this way, 40 systems are storing this RTD1 data. And all these 40 systems will be running parallelly, processing this 2 TB data. And that output will be collected by the next one. So here,
So the
once
partition will
our
be defined by system, or we need to define it based on the key.
default, see here, uh, partitions, even we have got that option to, we can also have our partition, how many partitions you want. Even in the Spark, we have got, we can control it. We can provide that number of partitions required. Okay, otherwise by default it will take. We can also provide how many partitions we want.
Okay.
This what, right? So just okay, one second. Resilient distributed data sets, right? So my more discussion will be on data frames. My more discussion will be on data frames, but before that, you need to have the Spark data objects like RTDs, basic entities of Spark. On top of that, only data frames are created. Okay. So tomorrow, so there will be a change in the link. Link will be changed. A new link you will be getting to your mails. People who have already got enrolled, people who have already taken that package, right? You'll be getting the link to your mails. Follow that new link. And people who didn't enroll, try to get enrolled for getting the new link. So from tomorrow, a WhatsApp group will be created separately for this Databricks. So we have got a lot of things. We need to set up the environment, Databricks environment setup. I'll be discussing step by step. I'll be discussing. People, you can do parallelly along with me. Before that, if anyone doesn't have free subscription, take a free subscription. Not now. Just I'll say it takes 2 more days. Like we have got some discussion. This fault tolerance mechanism in Spark, how the fault tolerance mechanism, right? And the other things I'll be discussing. So tomorrow, a WhatsApp group will be created. From tomorrow onwards, daily, you'll be getting the videos to your Google Drive. As of now, I think to your mails, they are forwarding you the video link. Have you checked your mails, right? Into your mails, you got the video links of the previous classes. From tomorrow, you'll be getting to your Google Drives. From tomorrow, you'll be uh, added to the WhatsApp groups, right? You can see a big messages given by this online team. For people who have not enrolled, a big message is given. You can copy that for, yes, link will be changed from tomorrow. Yes. So recordings from tomorrow, you'll be getting the recordings of it to your Google Drive. A separate drive access you'll be getting for this Databricks. From tomorrow, you'll be getting all the previous videos, including today's video, you'll be getting in your Google Drive. Today by evening, you'll be getting it. So get enrolled for getting the notes, videos, and this getting added. And the link you'll be getting to your Gmail, right? Fine. So I'm stopping here. We'll continue tomorrow. I want the sessions to be more interactive. Everyone, you can ask the queries. I'll be providing you more examples. This is just an introduction, right? On this, okay. But our major discussion in the Spark will be on data frames, data frame API, various built-in functions provided by this data frame APIs, right? We'll be discussing. Okay. Before I go with that in the practical part, I'll be discussing about the Azure Data Bricks environment setup, Unity catalog setup. In the interview perspective, right, they'll be asking a lot of queries on this Unity catalog, and very latest, very recently, right, from the Spark 4.1 version onwards, we got the concept of DLT, Delta Live Tables, right? DLT pipelines. DLT pipelines means how we can execute a DLT pipeline and using these annotations and using Python annotations, right? How we can directly create a tables like that. And even interview per point of view also, they'll ask, right, if you got knowledge on DLT and have you DLT pipeline execution, how it happens, everything using SQL approach and using PySpark approach I'll be discussing using SQL approach and using Python approach. Both I'll be discussing, right? Yes. Okay, fine. So I'm stopping for now. You'll continue tomorrow. More discussion on this same time at 6 o'clock tomorrow, but the change in the name. Check it. Okay.